As an operator, it is important to understand how a disconnect switch is used to ensure that an electrical circuit is completely de-energized for service or maintenance, as well as how a transfer switch is used to switch a load between two sources. These are the objectives for this course. Transfer and disconnect switches provide flexibility within an electrical distribution system. They can be used to change the lineup of the system or to change the power source to loads within the system. Disconnect switches are two-position switches used for the isolation of power to one or more loads, or motor control centers. They may be used in pairs to transfer power supplies from one source to another. 600-volt AC disconnect switches that are enclosed and that may be locked in the off position are called safety switches. Most disconnects have this ability, which allows maintenance to be performed on the associated piece of equipment being supplied by the disconnect. Disconnects differ from breakers in that they are not all designed to be opened under load. A disconnect design does not include arc chutes or any other means to extinguish the arc that is formed when the disconnect is opened. Before a disconnect can be opened, all equipment that the disconnect feeds must be verified as not operating. Opening a disconnect under load can damage the disconnect and cause personnel injury. The operator must don electrical gloves and stand on a rubber mat. Also, stand to the side and look away while operating it. Transfer switches are used to make and break circuits as required by sensing and transfer schemes to provide smooth power transactions. The transfer switch can be manually operated or automatically operated. Manual transfer switches are similar to disconnect switches, except they have three positions that allow the power supply to a component to be switched from one source to another. Automatic transfer switches can be used to disconnect a de-energized secondary bus quickly from its normal power and reconnect it to a backup diesel generator. This ensures that a source of power will be supplied to essential loads under most circumstances. Automatic transfer switches are normally grouped into two categories: normal seeking and power seeking. Normal seeking transfer switches are designed to prefer one power source, primary source, over any other. This means that the transfer switch monitors its normal power supply at all times. If power is interrupted to the normal supply, the switch will transfer to its alternate source, providing power to its load from the alternate source. When power is restored to the normal source, the transfer switch will automatically return to the original power source. Power-seeking transfer switches do not make the distinction between power sources. If power is lost to the source supplying it, the switch will transfer its loads to another source. It will not automatically shift back once power is restored. If it is desired to have the switch powered from the original source and the secondary power source is still available, it must be manually transferred using a reset button on the switch.